Hi class, this is course 3, lesson 47, graphing functions. Okay, so in this picture here is an illustration of a function, and it has 3 different parts. It has an input, and then that input goes into the function, and the function is the numerical machine, the part that will transform the input, and then it will come out of the function as an output. We've already talked about this piece right here. A function may be described as a function rule, may be a description, so that's words, an equation, a table, a graph. Okay, so there's different ways that you can represent a function. A couple things here. Under input, you have the word domain. Okay, and I wrote that down here for you. Domain is going to be an important vocabulary word. The domain is the set of inputs. In other words, it's what values can X be. Now remember, X could be R, or it could be D, it could be a different variable, but in this case, when we're talking about our input being X, so whatever your input is, it's what values can that be. That's your domain. So your domain, your X, your input, all different ways to describe that input, goes into the function machine, and a function, remember, produces one output for every input. Now the thing to note is that your outputs can be the same. So you can have an ordered pair 1, 3, and you could have an ordered pair 2, 3. That is still a function. We have an input of 1 and an input of 2, and they each produce only one output. Doesn't matter that they're the same output, it's just that it couldn't, we couldn't have another 1 as input up here with a different value other than 3. Now our range, that goes with the output. It's the set of outputs, or what values can Y be. Okay, so 2 important terms, domain and range. Domain is your input, range is your output. Okay, this is an example of a step function. Okay, again, another important term, a step function. That's a graph that has a stair-step pattern. It's not continuous. We can't draw a line through these because, well, it doesn't include all of the points in that fashion. Okay, so here's the scenario for this graph. A gym has a youth event schedule for children ages 7 to 16. And then the rules for the events would be that you cannot be 17 at the time of competition. Okay, so let's take a look at this. The solid circles and the lines, they include the points, the value on the graph. Okay, so let's look at this. So this point right here, solid circle, says that if you are 7 years old, you will start at 8 o'clock. And it continues that if you are up to 8 and up to 9. Now, 9 is an open circle. Okay, let me do this for you. Open circles. And the solid circles would be like these as examples. Open circles do not include the value. Okay, and if we look at this, it looks like that our input of 9 has 2 outputs. It looks like 9-year-olds could start at 8 a.m. or at 9 a.m. But because this circle is open, 9-year-olds do not factor into this starting time. So all the way up to, like, say your 9th birthday is tomorrow, you would start at 8 a.m. But if you are already 9 years old, you start at 9. And then if you're almost 11, you'd start at 9, but as soon as you turn 11, you start at 10. Okay, and these are very distinctive patterns. They don't, we don't have a line through there that says, well, when you're 7.5, you start at 7:45, okay, or at 8:45. You start at 8 up through this age, and then at 9 up through this age, and at 10 from 11 years to up to 13. Okay, so now let's answer the question, what is the domain? Okay, now remember, domain is your input or your X values. Your input is right here, your age of your athletic participants. So depending on how old you are, depends on what time you start your event. So the domain in this case would be the numbers 7 through 17, and then you might want to make a note that says it does not include 17. Okay, so in this case it's a very restricted set of numbers, set of values. It's only 7 up through but not including 17. What about your range? The range in this case is 8 a.m. through noon. Okay, it's the set of output values, and it's either 8, 9, 10, 11, or 12. And maybe more specifically, it's not 8 through noon, it'd be 8, 9, 10, 11, and 12. We would describe this if it were the whole numbers between 8 and 12, but we could just put on the hour between 8 and noon, something like that. Okay, so this is a step function. Looks like a stair step. It's not a continuous function. Now let's take a look at the function perimeter equals 4 times s. That is perimeter of a square given your side length of s. Oh, there should be a parenthesis back here. What is the domain for this function? Now, the value that we get to choose is s. So this is your input. And you're going to say, well, why do they put these backwards? Why do they list the output first if we know the input? Well, it's because we want to find the output, so we say, well, the output is a function of the input. And so we calculate what this value is, so then we can say perimeter equals whatever. Typically the value that the variable that is first and is equal to some operation is going to be your output. So what is your domain? What values can you use for side lengths? And in this case, you might want to think about different squares that you know of, but you could say, well, it could be 1, it could be 2, it could be 3, and it can be. Except it can also be a half. It can be 5/8, it can be 3 1/4, it could be 5 and 5/100ths, 5 and 5 2040 seconds. Okay, it can be any of those decimal and fraction numbers. What it cannot be is negative. So in this case, our domain is going to be all positive. And then what we're going to say here is real numbers, because we have no restrictions on whether it can or cannot be a fraction or a decimal. Doesn't matter. Lengths come in all sizes except for negative. Now what about our range? Okay, so if I take a positive real number and square it, I'm only going to get positive real numbers as my output. Okay, so let's bring up the example here. Looks like this. Here's a graph. We did the input-output table here, a function table with the side length and the perimeter, and we calculate what our output is, and then we graph them. Side length here, perimeter on the y-axis, and you can see that we never go negative, and it's always going to go up. We can continue going this direction, all positive real numbers, and we will just increase our values up the y axis. This type of function is a continuous function. Okay, and I believe I have that on the next slide. Yep, there you go. Continuous function. There are no gaps in the graph. Now compared to that stair-step graph where it went like this, it had an open circle and then a closed and then open, there's gaps, right? It doesn't just flow nicely. It goes here and then it jumps, and then it goes here and then it jumps. This has just a nice flow. It's continuous, no gaps. So that's another term that you need to know, continuous function. And the last thing that you need to know is direct proportion. In order for it to be direct proportion, the graph has to begin at the origin, it does, and all points in the graph are aligned, which means any two points or ordered pairs will form a proportion. So we have some up here, we have 1 to 4 has to equal 2 to 8. Is that true? Forms a proportion. So direct proportion means we're going to vary directly. Our input will always have a constant. In this case, it's times 4. Okay, so that's graphing functions. Maybe a little confusing. It's just a lot of vocabulary. If you refer back to your notes or ask a lot of questions, you'll do just fine. Okay, I will see you in class.